And then there is part D. You know, I'm starting to regret how many questions I give people on this worksheet. Hydrogen peroxide, H2O2. It is a liquid. It's added to acidify potassium permanganate. Well, I guess it will be dissolved in water. You can go with AQ. Added to acidify potassium permanganate, which is an A solution because it's a acidify, which means you can use cohes. I think they just stopped giving you any information here. Oxygen is evolved. Okay, this is not enough information. You also need the manganese to be reduced, Mn2+, which is something that you are required to know, that if you have permanganate ion, it's going to be reduced Mn2+. I will explain that in class, but anyway, this is good because it's an exception. So +7, +1, and 0 and +2. So there is an increase in oxidation number of oxygen from -1 to 0, which means this is your reducing agent. Potassium permanganate is a very, very strong oxidizing agent, so it will always get reduced to Mn2+. I don't think it can go up anymore. That's why, which is another thing I probably should explain tomorrow. Okay, can I split anything? Yes, this is a covalent substance. You can't do anything to it. But KMnO4 is K plus and MnO4 minus because it's aqueous and it is ionic. So I could just use the permanganate part. And then we have that equation once again. Actually, let's do oxidation first. We have H2O2. It's already exciting for me to write an equation that's not permanganate ions, because I write that thing every year so many times. 2 electrons. Yep, -1 to 0, so lose 1 electron each. 2 oxygen atoms, 2 electrons should be lost. And then for the reduction, MnO4 minus, AQ going to Mn2 plus, so we're going with 4H2O, 8H plus, and 5 electrons. Alright, I am going to multiply this one by 4 so that it has 8 electrons to match the reduction when I add the two equations together. So we'll have 4H2O2 aqueous plus MnO4 minus and 8H plus. It's going to go to 4O2. Oh, I was being silly. I shouldn't have done that. I should have written everything that's not hydrogen because you do need to cancel some of them. So Mn2 plus AQ. I think the water is fine though. I think there's only water in the reduction half equations. So 4H2O liquid. You have 8 hydrogen on the product side, 8 on reactant. Oh wow, perfect. It cancel out. You don't have any of it. Now let's just check the. This is so odd. Oh no. No, it is odd. What did I do wrong? The charge is not correct. This is 2 plus on one side, minus on the other. I have done something weird, have I? I don't know what it is. Let's just check. Oh, I know what it is now. This is really funny because I just said earlier that I wrote this question so many times and then I decided to multiply this by 4 to match that, even though if you multiply 4 it wouldn't work. This is why you check. People make mistakes. It's okay. What I've done is I have multiplied the electrons by 8, which will not match that because I was looking at the hydrogen ion instead of electrons. This is what happened when you do this for too long. You just start to stop caring and then you make a mistake. So you should always focus, guys. Alright, I had to multiply the first half equation by 5 and the second one by 2 so that you have 10 electrons for each of them. And now we're going to do the overall, hopefully correctly this time. So H2O2, I am going to just write the species that is not going to change first. And then this side we have 5O2 and 2 Mn2 plus and 8 H2O liquid. All right. 5 and then 2, so you should have 10 hydrogen ions on the product side and 16 on this side, so we're going to have 6H plus here. Okay, let's just check the charge now. 6 plus 2 minus is 4 plus. That's 4 plus. I'm super paranoid now, so I'm just going to check everything. So that's 10H. 6 is 16. That's 16. We have 10 and 8. So 18. 10 and 8, so 18. And 2 manganese on each side. I think that's the end of part D, finally.